installing an EV charger in your place, and if you think it's difficult or other people have actually turned the job down because it was too hard to install it, even if it's too difficult or even if other tradespeople turn this job down, we will find a way to make this work. Today we've got a Hypervolt Pro 3 EV charger which we are installing. This installation is slightly different than all the other ones, as we already have an existing feed from the property going all the way into the garage. What we are doing is that this feed is protected by a small little consumer unit. There's a 10 square millimeter SWA going all the way into this unit. We will put bidirectional RCBO into the garage unit, making sure that it protects all the DC backflow that the EV charger can under fault conditions to obviously flow back, and we need to put a protection for that exactly. And then we're actually installing an EV charger on the back wall on the outside of this garage. Firstly, there's a few things that we need to take into consideration. So the maximum demand of the whole property, what loads they are, how likely the client is to actually overuse this supply. So there's 100 amps main fuse for the whole property, but this is spliced off the main supply cable, and it has 50 amp MCB protecting this 10 mil square cable. Based on that, we'll calculate maximum demand. We'll make sure the client is at no condition will be able to overload the installations. We'll check the loads in the property for like showers, induction hobs, and the number of these items, if they are at all. Calculate all of it, making sure we're nice and happy. We will also put a CT clamp right here, explain to the client what is important and what are the risks associated with overloading the supply, in case in the future they would want to add some electrical showers or high loads, or maybe a hot tub, or maybe like a sauna. So there must be a different provision that we will need to do later at the time, making sure that everything else is safe. So let me show you around what we're dealing with. And the Hypervolt Pro 3, an old Proteus garage unit. These are the two circuits, but actually one of them is feeding an outside shed, which now will be disconnected. So we will shift over this RCD onto that side. We will have a room for RCBO unit to go straight in between the main switch and the RCD. That's what we are going to do. We need to find out which one of these two is actually feeding the outside shed. Feeding the cable all the way around here, around there, clip directly into this wooden joists here, and approximately on the other side of that wall will be an EV charger, which will be conveniently for my client to feed the cable under the gates and charge his car. Just around there, you see that tape. We will do a back entry, so nice and clean, only an EV charger on that side. This is the tethered unit, so I might put the actual tether hook on the left side of the EV charger, just keeping this nice and clean. As you come in from a shopping, maybe you have a big shopping, maybe you have a basket or something holding right in front of you, you don't want to caught up on that handle. It is important to think about all of these little things because they will have huge day-to-day implications when you leave here and when you're using the installation. That's what we do. Let's get going. This is a 100 amp fuse TNCS earthing installation, and here is our fuse box. So we've got two 16 mil tails going in the earth. This is coming from the SWA, and there is another earth coming from the property. What we're going to do is we'll actually test to see what ZDB, ZE we are getting on this fuse board, and then we do a ZDB on the other fuse board as well. So this will be a main supply, an isolation switch with the fuse, and then we've got actually a DB isolation switch. That's how you have to do it in your certificate as you do. So main overcurrent protection device, an isolation switch, and then a fuse board. Cool. Earth loop impedance at the board. The second test we will do actually ZE, so we will disconnect the main earth and we will check what readings we are getting with the external impedance. This is the earth loop path. We're looking for a nice and low reading, 0.35 for TNCS earthing, so this is where the earth comes from the back of the neutral. We'll go to Z settings, loop impedance. This will indicate our voltage. ZDB first, earth, neutral, and live, usually in this order. And now test. Okay, we need to give a bit more juice to my tester. Here we are in the shed. We've got this flex freed up, and we can see that these are passing through only. We'll have to figure out what's what. we can see that the incoming cable, we've got flat twin and earth, it looks like 2.5, and we've got passing by the black cable, which just passing through and it goes back, and there is that water fountain. So maybe this will reveal if it's one of these switches is actually doing the water fountain. So here we go, black and red, neutral, and brown and blue. It's a flex cable, so yes, this was a supply for the outside, so we were switching it. But what else we have is 2 lights. I presume that's 1, and that's 2. Cool, that's all sorted. We know what's what. Let's disconnect. I just want to make sure that all of the conductors are separated, just like so. I'm gonna go energize it, confirm that it's live, and then pull that fuse. So obviously I tripped the RCD. Let's put the RCD back. We know this hot tab is just supplying 1 socket right there. So let's re-terminate these cables back in there. Okay, so it's live. This will be live as well. I believe if I pull this fuse, this will stop outside. Yep. As the idea was to keep all the sockets in the garage, just have the back shed disconnected. That's what we're gonna have. So this is a solution I've used because removing cable is easy. Putting new cable is not as easy. If we might find a use for this in the future, when a new shed goes up or something, when my client will be like, actually, I'd like to have a socket on that side of the garden. What we're gonna do is we'll coil the cable, get it out. We can either cut or hide conveniently somewhere in a corner. And if it comes to do anything with it, we can just repurpose it. If we can repurpose any of the existing installation, why not? Making sure it's all nice and safe. Let's disconnect this. We just need to reconstruct this slightly. What I need to reconstruct is move RCD over to one side, put a different bus bar, so shorten it by 1, remove one of those MCBs. One of these bad boys needs to go. We'll just put all the 3 conductors into that one. They're all serving low power equipment like freezer and nothing else. Maybe a battery charger for power tool.
A few moments later.
Okay, let's move on with this installation. That's where we are going. So 6mm non-armored EV Ultra. That's what I think. We can do a top entry as there is plenty. Okay. Inside EV Ultra cable, you got a few other cables as well. These are just helping to keep the cable in a round form. That's our data. Earth, live, and around live we got some other cables. And here we got blue. Live on the left, neutral on the right. The plan is to do a back entry on the cable. We're going to put this seal on top of it, as this will create, this is an intermittent seal, the one we use in the fuse board. This pad goes in, then we push a cable in. It's a fire rated grommet, so these are the strings. So all the white strings, they are like inside. The green ones, they were like around it. Now I've got just a cable left, create small hole. Because we drilled right at this angle and my cable is pointing down, but the exact hole, you see how tight and nice it's around the cables, and my cable entry has to be like that, nice and straight. So I just need to chisel off, allowing my cable to go nice and straight. Nice. Let's put the crimps on. Insulation resistance, R1, R2, earth, neutral, and we have live, so we're just doing ZDB. 242, 242, 0.24, 0.95 Ka. Let's check what the ZE for this fuse board is going to be. 0.63. We've got combined. So we've got this. We also have the one coming from the actual SWA, and 0.36. And we'll change it to installation resistance. Live to neutral. And we go 500. And we get 999. Beautiful. Live to earth. Beautiful. And earth to neutral. Couldn't be anything different. No. 2 of these. And resistance. Yeah, that's fine. Let's just double check the cable. So I've cancelled. Okay, 15. I remember 15. So earth and live. On the other side, we are going to clip them just using this. They're making good contact. Let's check the resistance of R1 and R2. And that is 0.01. That will do. So firstly we will do ZS test, and then we are gonna trip the RCD 6 times. Z. That's nothing. If I press now, it's gonna wait for available voltage. And that's what we're gonna do. That's what we did. Now it shall perform the test, and the test is 0.31. Let's change to RCD. It's going to go through half time, 1 time, 2 times, 5 times, and ramp test. So let's go for it. We tested the polarity doing a ZS test. Okay. It's going to go through half time. It's going to go through half time on the AC wavelength 180 degrees, and that shouldn't trip, and that was times 1. So 5 more, 4 more, 3 more, 2 more, 1 more. And that will be all of the tests. I can just let it go. Leave it. It was 10 tests, 8 times tripping. For the first 2, it wasn't tripping, and for the rest of the 8th, it has. Grab some evidence for later. Like this. And let's review it. The highest number, times 1 at 180 degrees, 37.2. And yeah, 24 milliamps ramp test. It's all right. This is not to be done very strong, so if you're on impact driver, you have to be very gentle. Usually when it goes on the ratchet like this, you want to stop and go around with a hand driver. That's it. Do it with the easy. Okay, cool. If there is an easier EV charger to be installed out there, let me know. Well, I'm not talking about ohming type of thing, like a big extension lead thing. That doesn't count. Very nice. Even if it's too difficult, or even if other tradespeople turn this job down, we will find a way to make this work. We can repurpose some of the existing installation. Just give us a call. We're always happy to help. So another Hypervolt installed. We are off to the next client. Let's move on.